Now let's understand different types of quadrilaterals. We'll start with a trapezium. Now what is a trapezium? A trapezium is a quadrilateral where one pair of opposite sides are parallel. So if you visualize, it will look like this. This will be a trapezium where these two sides are parallel. These two sides are non-parallel. Now, if these two non-parallel sides, if they are equal in length, then it's called an isosceles trapezium. Now, when both the pairs of opposite sides are parallel, then that kind of a quadrilateral is called a parallelogram. So if you visualize, it will look like this. These two are parallel. These two are parallel. This is a parallelogram. So here, these two sides are parallel. These two sides are parallel. That means both the pairs are parallel here. So this is a parallelogram. It's very easy to understand. So trapezium is when one pair of opposite sides are parallel. Parallelogram is where both the pairs are parallel. Now to make it interesting, let me show you how we can convert an isosceles trapezium into a parallelogram with the same area. And I'm sure you will like it. So let's take an isosceles trapezium like this. These two sides are parallel, these two are non-parallel. Drop a perpendicular. This point join with the midpoint of this side. Shade this triangle. Just flip the shaded triangle. There you get a parallelogram with the same area because there's no change here, right? So very simple and interesting. So as you already know, parallelograms are nothing but where both pairs of opposite sides are parallel. Now let's look at different types of parallelograms. So in a parallelogram, so let's take a parallelogram like this where these two are parallel, these two are parallel. Now if I just cut here and if I make all four sides equal, this is called a rhombus. So a rhombus is a parallelogram where all four sides are equal. Now a rectangle is a parallelogram where one angle is 90. Effectively, when one angle is 90, or all four angles will be 90 degrees and equal. So let's take a parallelogram like this. If I just move it like this, it will become 90 here. All four will become 90 and this is a rectangle. Now to make it interesting, let me show you how we can convert a parallelogram into a rectangle with the same area. So take a parallelogram like this. Drop a perpendicular. Shade this triangle. Cut the triangle and just slide it like this. So you get a rectangle with the same area. Very easy, right? And interesting, intuitive. Just to make you think better, just to make you connect better, let me show you how we can convert. Let me also show you how we can convert an isosceles trapezium into a rectangle with the same area. This is also very, very interesting. So for that, let's visualize an isosceles trapezium like this. Now, drop two perpendiculars passing through the midpoints of both the non-parallel sides. So you get two triangles here. Shade the triangles. Rotate these two triangles like this. There you get a perfect rectangle with the same area. Very interesting. Now, next we look at squares. So what is a square? Nothing but in simple language, a parallelogram. You convert it into a rhombus and a rectangle together, you get a square. So what is a rhombus? Rhombus is where all the four sides are equal, and the rectangle is where all the four angles are equal and equal to 90 degree. If you take both together, you get a square. So in a square, all four sides will be equal, all four angles will be equal and 90 degree. And that kind of a parallelogram is a square. Now, to simplify, let's visualize this. Take a parallelogram. Now, if I cut here and if I make all the four equal, I'll get a rhombus. Just move it here to make it 90. So I get a square because now it is all the four sides are equal and all four angles are equal. So we get a square like that. Very simple, right? How we are converting a parallelogram into a special parallelogram which is called a square. Because square is also finally a parallelogram. Just like all rectangles are parallelograms, all rhombus parallelograms, all squares are obviously parallelograms. We also know that when two pairs of adjacent sides are equal like this, that is these two are equal and these two are equal, then we call it a kite. Now this is not like a trapezium because this is neither like a trapezium nor like a parallelogram, because in a parallelogram both pairs of opposite sides needs to be parallel, and in a trapezium one pair of opposite sides needs to be parallel. In this case only adjacent sides are equal, right? These two are equal in length, these two are equal in length, So this is called a kite. So now we know all types of quadrilaterals starting from trapezium to kites. Now just to make you understand that using a very simple diagram, maybe you can represent them like this. If we just summarize all types of quadrilaterals and if I present them all in one screen, it will look like this. A trapezium where one pair of opposite sides are parallel. Now if you look at different types of parallelograms, parallelograms is where both pairs of opposite sides are parallel. Now over there, in parallelograms, if four sides are equal, we get rhombus. If all the angles are equal to 90, we get a rectangle. Now if it's both together, then we get a square where all four sides are equal and all four angles are equal to 90. And kites are anyway neither trapeziums nor parallelograms. Kites are where adjacent sides are equal and they look like this. Using Venn diagrams, if you want to represent quadrilaterals, it will look like this. Now trapeziums, parallelograms, some of them will be rhombus, some of them will be rectangles. If I bring them together, the intersection, that is when it's a rhombus and a rectangle, it's a square. And kites are, you'll have to represent in a separate circle outside. And the Venn diagrams on quadrilaterals will look like this. It's very easy to understand. If you know Venn diagrams, you can easily connect how they are related.